Well, hello everyone, welcome back to Math Specials class. Now, we're going to learn about component of factors. Let's check this video out. We have learned about factor component of A and B before. As we have learned that component factor of A is 4i plus 2j because the component of A is 4 unit to the right and 2 unit upward. Right is positive, upward is also positive. And then for factor B is negative 2i minus 2j because it's 2 unit to the left, it means negative, and 2 unit downward, it means also negative. But how if the factor serve in this case? We don't know the unit, we just know the magnitude of the factor and also the angle. In order to find the component of factor, please follow the following steps. First, we need to identify which part is I component of A and J component of A. So this part is I component of A and this part is J component of A. Now, as you can see, for the I component is adjacent of this angle, so we're using cosine. Cosine 30 equal to adjacent per hypotenuse. I component of A per 10. So I component of A equal to 10 times cosine 30. That's the component of A in I. And then, in order to find the J component, as you can see, the J component of A is opposite of the angle. So sine 30 equal to A component of J per 10. So J component of A equal to 10 times sine 30. That's the component J of I. So factor A can written as this component. So 10 cos 30i plus 10 sine 30j. Let's move on to the example. Two forces are 5 Newton in direction from north to west in 20 degree and 10 Newton in direction 40 degree from east to the north. A. Show the forces on the axis given. First, let's deal with the 5 Newton in direction 20 degree from north to west. From north to west, this is the direction from north to west. As you can see, it's 20 degree and a 5 Newton force. So why the 20 degrees not in this part? Because we start from north in going to west. In this part is 20 degree, not in this part. Next, let's deal with the 10 Newton force in direction 40 degree from east to the north. So from east to the north, this is the direction. And then it's 40 degree, and then this is the force. The magnitude of the force is 10. And B. Write each of the forces in component form. Let's start with the 5 Newton force. Now we're going to find the I component and J component of 5 Newton force. So this is the angle. As you probably have known that I is the opposite and J is the adjacent side. So, in order to find the I component of 5 Newton force, so sine 20, we're using sine because I is the opposite. Sine 20 equal to I per 5. Or, on the other hand, we found that I equal to 5 sine 20. You can use your calculator to find the value of sine 20 and then multiply with 5, and you will find 1.71. That's the I component of 5 Newton. And then next move on to the J component of 5 Newton force. So this is the adjacent. It means we're using cosine. Cosine 20 equal to J per 5. The adjacent per hypotenuse. So J equal to 5 times cos 20. If you use your calculator, you will find that component J of 5 Newton force is 4.7. So we can write that 5 Newton equal to negative 1.71 I plus 4.7 J. Why this is negative? Because the I component is going to the left. Left means negative. And the J component is going upward. Upward means positive. So this is the form of 5 Newton force. Next, let's deal with the 10 Newton force. This is the I component of 10 Newton force, and then this is the J component of 10 Newton force. As you know, this is the angle, so for I is the adjacent and for J is the opposite of this angle, the 40-degree angle. So in order to find the I component, we're using cosine rule. Cosine 40 equal to I per 10. So the I component equal to 10 times cos 40 equal to 7.66. You can use your calculator to check this number. And then how about the J component? Component J of 10 Newton force, we're using sine. Sine 40 equal to J per 10. So J component of 10 Newton is 10 times sine 40 equal to 6.43. And you can write 10 Newton component is 7.66 I plus 6.43 J. Both of component positive because the I is to the right and the J is upward. So both components are positive. Next, determine the magnitude and direction of the resultant of two forces. First, let's deal with the magnitude. So, like I explained the last week, that the magnitude is dealing with the nose and tail. As you can see, this force is tail meets the tail. So we move this factor here. So nose meets the tail. This is the factor resultant of these two factors. Okay, this factor is 5 Newton factor as we have found the component, and then this is the 10 Newton force, and this is the component that we have found. Okay, so the resultant of both this factor is actually an addition of both factor. So we just simply to add this factor and this factor. Okay, addition with factor, we add the I component with I component and the J component with the other J component. So R equal to 5.95 I plus 11.13 J. That's the element of factor resultant. Now we're going to find the magnitude. As we have found the component of factor resultant, we can find the magnitude. The magnitude of factor R as a factor resultant is square root of 5.95 square plus 11.132. We add those numbers together and we find the square root of that number. We'll find 12.62. You can check by your calculator. Okay, this is the magnitude of the R factor resultant of R. We have found the magnitude. Now we're going to find the direction. How to find direction of this vector? The direction. We have found the component of r is 5.95i plus 11.13j. We going to find the angle, this angle, to identify the direction of this vector. Okay, how to find this angle? We using tan. Tan of theta equal to opposite for adjacent, 11.13 per 5.95. So by your calculator you can check that you'll find the theta equal to 61.87 degree. So this is 61.87 degree, and the direction of this vector is 61.87 degree from east to the north. As you can see, this is from east to the north. So in 61.87 degree from east to the north.